Hello everyone. If you enjoyed the 10 days of JavaScript, you might be happy to know that the complete 27-hour full stack course has just launched. There's a coupon link to join at the lowest possible price in the description for this video. The remainder of this video picks up right where the final 10 days of JavaScript video ended, and this serves as a sneak preview into the full course. I hope this video helps you get started with Node. Have fun, and I'll see you around. If you want to learn JavaScript full stack from scratch, you've come to the right course. Because I've spent the last 14 years living and breathing JavaScript and web development, and now I'm here to teach you everything I know. Here's a quick summary of what we're going to learn. The basics of computer programming in general, the JavaScript language itself, the Node.js environment and how to use it to power a server. We will learn about the web browser environment and how to use JavaScript to control it. We will learn what a database is. In particular, we'll learn how to use the MongoDB database system. We'll learn how to relate one piece of data to another. For example, letting one user follow another user. We'll learn how to update the browser in real time with fresh data from the server. We'll learn how to create real-time two-way communication of data. We will use it to power a chat room, but you could use this same technology to power a simple game or just about anything. We'll learn about authentication, both stateful with sessions and stateless with JSON web tokens. We'll learn about the MVC architecture pattern. We'll learn what an API is and then how to create our own API, and much, much more. 14 years ago, when I began my programming career, I dreamed of one cohesive course that I could start from scratch with and follow all the way to the end in order to gain a big picture understanding of how all the puzzle pieces fit together. I dreamed of a course that explained the why and not just the how. And over 14 years, I never did find a course like that, but I just created it. Now, I would love to have you come along on this journey with me, and if you're ready to launch your career as a full stack JavaScript developer, then I'll see you on the inside. Hello everyone, and welcome to the next chapter. Let's take a quick look at where we are. So we've learned the basics of the JavaScript language itself. We've also learned the basics of how to use JavaScript in the web browser environment. And now our next step is to learn how to use JavaScript in a server environment. But why? So we need to ask ourselves a few questions. What is a server and why do we want to use one? Let's start with what is a server. So when I visit google.com, my web browser sends off a request to the Google server. And the Google server sends back a response with the HTML to display this page. Now, when I search for something, so if in the main Google field I search for JavaScript, my web browser sends off a request to the Google server with JavaScript as my search term, and then the Google server sends back a response with the data needed to display these results. So what is a server? Well, my own oversimplified answer is that a server is the thing that we can talk to in order to send and receive data. As a user of an app or website, we can send requests to a server, and then the server sends back a response. For now, that's as deep as we need to go in terms of what is a server. Now let's move on to why we want or need a server. I would say there are two main reasons. Number one is directly related to what a server is, right? Communication. Our app needs to be a good listener, right? It needs to listen for incoming requests, and then it can send back a response. Or in other words, we need a way for our users to access our app. And that's the case even if we're building the simplest website ever. Even if it's just a simple brochure website that is literally just a headline that says, hello, even in that case, we still need a server that visitors can connect to in order to view the page. Even if that server is just serving up the file system and sending back statically created basic HTML files, It's still a server that's listening for incoming requests. Okay, so that's reason number one for why we want a server. Now here's reason number two. If we want to build something a bit more complex than just a static read-only brochure type of website, and we want to let our visitors actually perform actions instead of just viewing pages, we need a server of some sort. And the reason for this is because we cannot implicitly trust the web browser or incoming requests. Let me explain why and also just sort of what I'm talking about. For example, let's imagine that we wanted to use our bank's website to transfer money from one bank account to another. So instead of google.com, imagine right now I was logged in to my bank's website. Well, from a code perspective, perhaps the bank website would send a bit of JavaScript to me in my web browser. So maybe they would send over an object, money transfer, and you don't have to type this out. This is just for a quick explanation. There's no need to follow along with this code, but maybe the bank server would send over to me an object, so say money transfer equals, and they would set the from account to whatever my logged in user is, right? And then the to account would be whoever I wanted to send money to. So they would probably pull this value from the input field of whoever's name I type in. And we could imagine there would be a property named amount, which again would pull in the value of a user input field of how much I want to give to someone. And then finally, we could imagine there would be a property named message, which is a place for a memo or a brief description of the money transfer. Now, most people are not evil, and most people are not familiar with code and their browser's console. However, what if we were an evil or malicious user? We could log into our bank's website, come into our browser's console, and we could just change this stuff programmatically, right? We could fire up our console and say money transfer dot from account should not be the logged in user that I actually am. It should be really rich person Smith. And the to account should be me. Give me the money. And the amount should be some disgustingly large amount. And the message should be, ha ha ha, my money now. Right? Now I could add that into my web browser's memory. And then if I went back to the bank screen, I could click a button that says perform money transfer. And if the bank's server implicitly trusted me, I would now be a very rich man, right? The request would go through. Now, obviously, that's not the world we live in. If servers implicitly trusted you and your requests, the world would spin out of control into complete chaos in about 2 minutes. The reason we have any sort of sanity in this digital age is because a server has the job of making sure that you really are the person that you're claiming to be. Now, you might be thinking to yourself, why couldn't we just use JavaScript to send over an if statement to the web browser? Right? We already learned how to make decisions in our code. So imagine the bank assigns you a variable when you first log in, maybe let user equal your name, right? And then maybe you think we could use an if statement and say only if the following is true. Only if user equals money transfer dot from account, right? So only if this is the case. Only if the user is who they say they are, then let the money transfer go through. Well, this line of thinking is good. This is similar to the line of thinking that we would use on the server side. The problem is just that we cannot rely on this on the client side or the web browser side or the user side. Because there's nothing stopping a malicious user from simply saying, well, user should equal really rich person Smith. Right? They could modify the user variable in their web browser, and then this if statement would evaluate to true. Or better yet, a malicious user could simply modify the JavaScript that you send over to them and just get rid of the if statement check. Or a malicious user could just completely disable JavaScript in their browser entirely. So getting back to reason number 2 of why we want a server, trust issues, we need to run this decision-making code in a trusted environment. And we can never truly trust the user's web browser. So the idea is that with a server, we can write JavaScript code, we can write if statements and all sorts of things to make sure that it's a legitimate request. So long story short, a server is really just a place where we can write code that cannot be tampered with or manipulated by the user of the application. And for now, that's really as deep as we need to go in terms of why we want or need a server. Now, before we bring this video to a close and start talking about our next steps, I first want to address two common questions that you might have right now. So question number one, you might be thinking, okay, sure, so you could write this if statement on the server side, but couldn't the user still just send along a fake user value and try to impersonate someone? And the answer is yes. Malicious users will try to do that. However, I don't want you to worry about that right now. We are absolutely going to learn about authentication later in this course, but I don't want you to burden your mind with it right now. Don't worry, we have a lot of tricks up our sleeves on the server side, and we can get creative in terms of making sure that users are who they claim to be. For now, all you need to know is that if our app is even going to have a chance of being secure, we need to run our verification and authentication code in a trusted environment, not in an environment that the user is in control of. So we need a server. Okay, so that's common question number one. Common question number two is, hey Brad, what about serverless applications? I keep hearing this phrase, serverless app. It's a really popular buzzword right now. There's a lot of hype surrounding it. So if an app can be serverless, do we really need a server? And my answer to this question is that it's really just a matter of semantics. Serverless apps still use servers. The difference is that instead of writing an entire server and then pushing it up onto the internet, with a serverless app, you're just writing individual functions and then you're handing those functions off to a big company like Amazon, Google, or IBM, and then those billion-dollar companies are hosting your functions for you. It's the same idea though. You are writing server-side functions, you are having a place that is trustworthy and private. It's just that you're letting some other company host your individual functions instead of you needing to host your entire server yourself. Now, if everything I just said made zero sense and you've never heard of the phrase serverless apps, that's okay. You can just forget the last 60 seconds ever happened. Rest assured that later on in the course, I will briefly talk about and explain serverless apps. But for now, we do not need to worry about that. And I can tell you with the utmost certainty that whether you want to create a traditional app or a serverless app, you are going to need to write server-side code. And in the JavaScript universe, as soon as you want to start writing code outside the context of a web browser, you need to learn about something named Node.js. After the web browser, Node is by far the most common or popular JavaScript environment. Now, Node can be used for just about anything, so I don't want you to think that it's just for creating servers. That just happens to be one of its many use cases. Big picture, learning about Node is going to open up so many doors for us, and it's exactly what we're going to start learning about in our very next lesson. This is an exciting portion of the course because when you start to learn about Node, you can legitimately call yourself a JavaScript developer. So let's keep our momentum rolling, and I will see you in the next lesson. Hello everyone. In this lesson, we are going to get started with Node.js. However, before we download and install Node onto our computers, let's first ask ourselves, what exactly is Node? So very early in the course, we learned that there are multiple environments in which we can speak the JavaScript language. And each environment has its own unique made-up words or slang or lingo that relate to its superpowers or abilities. So the web browser is a JavaScript environment, and its special abilities include viewing web pages and responding to user events like clicks and keyboard presses, so on and so forth. Well, Node is another JavaScript environment, and its special abilities include things like being able to create new files and folders on your computer's hard drive, being able to listen for incoming network requests, and much, much more. In other words, the web browser can do web browser-ish things, whereas Node is more open-ended. Node can do general computer-ish things. For now, that's all we need to know about Node. So that's enough talk for now. Let's get to the action. Right now, let's go ahead and download and install Node onto our computers so we can get started using it. So follow along with me. Here is the official Node.js website. It's nodejs.org. I will include a link to this website in the resources for this lesson, or you can just perform a Google search for Node.js. Okay, and from the website, we want to download it. In my case, it says download for Mac OS. In your case, it might say download for Windows or something similar. Now, the version numbers that you see in this video are going to be different when you actually visit the website yourself, because Node is constantly releasing new updated versions of the software. That's okay. Your version number does not need to exactly match my version number. Now, there are two different download options that we see here. One with the absolute newest, latest, and greatest features, and another one that is slightly older, but is super reliable and stable and dependable. Either download link will work just fine. You can't go wrong, but personally, I usually recommend the long-term support version. So go ahead and click on that to begin the download. Depending on the speed of your internet connection, it could take a while, but once the download finishes, go into your computer's downloads folder and open up the install file. All of the default options in the automated installer are A-OK, so you should be able to just click next, next, next without any trouble. So at this point, I'd recommend you pause the video lesson while you go and install Node. And once the installer is complete, you can come back and resume the video. Okay, our next step is to make sure that Node was successfully installed. To do this, we want to open up a command line on our computer. If you have no idea what a command line is and what you're looking at right now on your screen, don't worry, don't panic, that's okay. I know from firsthand experience that when you first see a command line, it can be terrifying. But if someone's guiding you through things and holding your hand, it really doesn't need to be scary. Whether we like it or not, if we want to become a full stack developer, we absolutely need to use a command line. There's just no getting around it. So the question is, how do you open up a command line on your computer? Well, it's going to be different depending on whether you're using Windows or Mac. Okay, so on Windows, you can open up the Start menu and then just start typing on your keyboard, start typing command prompt. It should show up in the list of programs or applications, so go ahead and open it. Or another way to get to the command line on Windows is to just hold down the Windows key on your keyboard and simultaneously press the R key. This will open up a run prompt, and click into the run prompt field and type CMD and then push enter. Okay, so that takes care of Windows. If you're on Mac, simply look in your applications folder for another folder named Utilities. Inside the Utilities folder, you will see an app named Terminal. Terminal is the command line on Mac, so go ahead and open that up. Okay, at this point, everyone should have a command line open. Now I want you to type this in. Node, and then a space, and then dash, or the minus sign, right? And then V. So node space dash V. Go ahead and push enter. And in response, your computer should output a version number of Node. If you see something similar to this, even if your numbers are different, that means you have successfully installed Node. Give yourselves a pat on the back. If you do not see a version number after running node space dash V, and instead you see something like unknown command or command not found, that means there was a problem when you tried to install Node. If that's the case, you can try restarting your computer and then opening up the command line and trying this again. Or you could try running through the Node installer file again. Or you might need to do a bit of personal Google research. I'd recommend searching for install node problem blank, where blank is your operating system. Because there are unique potential issues that are slightly different for Windows 7, Windows 8, Windows 10, as well as the different versions of Mac OS. There's also a lot of different personal variables as to why Node did not successfully install, such as the antivirus software that you have running in the background, or different security settings that you have enabled on your computer, so on and so forth. So unfortunately, there's no way for me to preemptively list solutions to all of the possible reasons as to why Node didn't successfully install. However, I will say this, learning how to Google and perform research is a huge part of becoming a developer. So if you were not able to install Node successfully on your first try, don't worry. You're not alone. Whatever issue you're running into, someone else has already ran into that issue, and that's the beauty of Google. And as you're digging through Google results, I want you to be on the lookout for any stackoverflow.com results. A common joke in the programming world is that developers get paid to Google and find answers to their problems on Stack Overflow. Okay, now at this point in the lesson, I'm going to assume that everyone has successfully installed Node if you're moving forward. So let's get our hands dirty and get our first taste of Node. In the command line, I want you to simply type node, no space, nothing else, just the word node, and then push enter or return. By doing that, we have now entered into an interactive Node environment. In other words, we can start speaking the JavaScript language and our computer will understand us. So we can say 2 plus 2 and push enter. We see 4. This is very similar to earlier in the course when we first started to experiment with the web browser's console. Basically, right now, we are in the Node console. So we are free to speak the JavaScript language. We could create a variable, say, let my favorite number equal 10. Push enter, that gets stored into memory. And then I could say 7 plus my favorite number. Push enter, we see 17. Now, what if instead of just simple JavaScript language features like this, we wanted to leverage Node's unique abilities and superpowers? For example, what if we want to create a server and listen for incoming network requests? Well, doing that with Node is relatively easy, but it's going to take more than just a single line of code like this. And if we're going to be writing more than just single line code examples, we really should be doing our typing in a dedicated text editing program instead of the command line. Just like earlier in the course when we moved from the web browser's console into CodePen so we could write multiple lines of code easily, right now we are going to move from our command line into a text editing program. Ultimately, the reason we are doing this is so we can begin to do actually interesting and complex things with Node. If you're scratching your head right now and still not really seeing the point of Node, and you're not sure what the goal of all of this is and why Node is necessary, don't worry. That's to be expected. I think the bigger picture of what's going on is going to come into focus and become very clear over the next several lessons. Trust me, when we finally do something interesting with Node and we see how that can interact with the web browser and how the puzzle pieces fit together, you are going to have an unbelievable aha moment. So let's keep our momentum rolling, and I will see you in the next lesson. Just a super quick note at the end here. To exit the interactive Node environment in your command line, you can just press Control-C twice. Or if I jump back into the Node console, another way of exiting Node is just to type .exit. It's not the end of the world if you don't exit Node like this, but it should make closing your command line window a bit easier. Alright, I will see you in the next lesson. Hello everyone. In this lesson, we are going to make sure that you have access to a text editing program on your computer. Before we worry about downloading and installing a text editor, let's first go over why we want one in the first place. So in our previous lesson, we installed Node.js, and then we learned how to access it from our command line. So if I type Node, I can then start speaking JavaScript. 2 plus 2, you get the idea. However, if we want to do something complex and interesting, we are going to need to write multiple lines of code. So almost as if you were writing a play or a movie or a TV show, you would need to write a fairly long script. Well, it's the same thing here. We want to be able to write a long script or a bunch of code and then feed that all into Node at once. Now, the way that this is typically done is by using a text editing program to create a JavaScript file on our computer's hard drive, and then we can feed that file into Node. Now, there are many, many different text editor programs in the world, and many of them are free to use. The program that I personally use, and also that I strongly recommend, is named Visual Studio Code. It's also often referred to as VS Code. So you can Google for Visual Studio Code, or as of this recording, the official website is code.visualstudio.com. It's completely free and completely safe to use, and it's available for Windows, Mac, and Linux. It's the text editing program that I'm going to be using throughout the course, so if you want to follow along with me step by step, I strongly recommend you also download and install Visual Studio Code. A little bit later on in this very lesson, I will explain why I think VS Code is such a great option. However, I don't want to be dogmatic, so I don't want to force my preferences or opinions on you. There are many other text editors that you can use. For example, Atom is a very popular text editor that's also free. Also, Sublime Text is another very popular text editor. Technically, it's not free, it's available for purchase, but you can use it for free to evaluate it and decide if you'd like to buy it indefinitely. The point that I'm trying to make is that there are many, many different text editing programs out there, so I don't want you to feel bad if you really don't want to use Visual Studio Code. However, having said that, my opinion is that you should give it a try because I think it's amazing. Anyways, having said all of that, right now I recommend you pause this video lesson while you download and install VS Code. Alright, at this point I will assume that you've had a chance to install VS Code, or you already have an existing text editor and you're fairly comfortable with it. So now let's give ourselves a goal of creating our first JavaScript file and then feeding it into Node. Now, instead of just creating a JavaScript file directly on our desktop or in some random folder, why don't we create a new folder on our computer specifically for this JavaScript file? So it doesn't matter where we create this folder, but for example, on my desktop, maybe I will create a brand new folder, and the name of the folder doesn't matter, but I will name it First Node Experiment. You could name this folder Testing or Pizza or Unicorn. The idea is that we just created a new empty folder, and now I want to open this folder with our text editor program. So right now, go ahead and open up VS Code, and there are several different ways to open a folder in this text editor program. So you can use the top left file menu and just choose File and then either Open or Open Folder. Or an even easier way is just in Windows or Mac to find that new folder that you created, and you can just drag and drop the new folder onto VS Code. So if you're on Windows, you can just drag this folder onto the VS Code program window, or if you're on Mac, you can drag your new folder onto the VS Code icon in your dock. Okay, now once you've opened that folder with VS Code, you should see a few options right about here. First of all, we can go ahead and close the welcome screen or any sort of welcome tabs. Okay, and in this left-hand middle menu that we see here we see the name of the folder that I just opened up, and if I hover over that little tab, I have a few different options. So this first icon will create a new file within that folder. That's what I'm interested in doing. I want to create a new file in that brand new folder. So you can either click this icon here, or you can click File, New File, it's up to you. Or you could even just right click anywhere in this empty space right about here and choose New File. At the end of the day, all we really want to do is create a new JavaScript file, and the name doesn't matter. I will name it test.js. The .js tells our computer that this is a JavaScript file. So the first part of the name doesn't matter. You could name it pizza.js or unicorn.js. Okay, after we create that file, VS Code opens it up, and within this main part of the screen, we can start typing. So just like before in the CodePen examples, we are free to write multiple lines of JavaScript within this new file. So why don't you type this out and follow along with me? Let's create a variable. So let's say let strawberry count equal 20. Okay, then below this, let's write an if statement and say if strawberry count is greater than 10, log out a message to the console that says you have enough strawberries. Otherwise, else log out a message that says you do not have enough strawberries. So we'll say if parentheses, curly brackets. Within the parentheses for our condition, we can say if strawberry count is greater than 10, then within the curly brackets, we can drop down and say console.log, you have enough strawberries. Okay, and then if this is false, if strawberry count is not greater than 10, down here after the closing curly bracket, we can just say else, curly brackets, log out to the console, you do not have enough berries. Okay, then push Control S or Command S to save this file, or you can just use File Save. And now the moment we've all been waiting for, let's feed this file into Node. Right? So instead of having the web browser execute this JavaScript code, we want the Node environment to execute our code. Now, in our previous lesson, we learned how to run Node, right? You need to open up your command line. However, this is one of the biggest reasons why I'm a huge fan of VS Code. While you're in VS Code, I want you to hold down the Control key on your keyboard and simultaneously press the tilde key, which is the key to the left of the 1 key, or it's also the backtick key, the key right above tab. So hold Control and the tilde key, and that opens up a command line directly within our VS Code program. This is incredibly convenient, and it makes our lives a lot easier. You can also access the command line in VS Code by looking in the top View menu and then clicking on Terminal. Now, if I was not using VS Code, I would need to open my command line like we did in our previous lesson, right? The command prompt for Windows or the terminal for Mac. But in VS Code, you don't need to jump back and forth between two separate programs, between your text editor and your command line. In VS Code, your command line is just conveniently right here. Another thing that's cool is VS Code automatically points your command line towards the current folder that you're working in. So usually in the command line, you would need to say cd space and then type out the directory of where you want to point towards. With VS Code, we don't need to do that. Our command line is already pointing towards our new working folder. So check this out. All we need to do to feed our JavaScript file into Node is down in the command line, write node and then a space and then the name of our file. So in my case, that's test.js. We actually do not need to include the .js. So you can just type the actual name of your file and then push enter. Awesome. We see you have enough strawberries. And if we come up to our JavaScript code and change the strawberry count to something really small like 3, and I save the file, and then I come down here and run that code again. So I say node test, you do not have enough berries. And again, if you named your file something different than test.js, you would not say node test. For example, if you named your file pizza.js, then in the command line, you would write node space pizza. Really, all we are doing is passing our file into Node. We're just saying, hey, Node, execute our file. Cool. Now, there's nothing very interesting or impressive about a simple if statement, right? However, we now have everything we need to really start rolling. We've installed Node onto our computers, we have a text editor program, and now we know how to use the command line to feed a JavaScript file into the Node environment. So I've got some good news. This means that in our very next lesson, we are ready to use Node to build our own small, simple server. This is where the big picture of what we are trying to accomplish is going to come into focus. I am so excited to write our first bit of real-world Node code with you. So let's keep our momentum rolling, and I will see you in the next lesson. Hello, everyone. In this lesson, we are going to create our very first server. Without further ado, let's jump right into the action. So go ahead and make sure that you have the folder that you created in the previous lesson open in a text editing program. And here we can see that I have opened the test.js file that I created in the previous lesson. Let's go ahead and erase or delete everything inside that file and give ourselves a clean slate. Or if you wanted to, you could just create a brand new file within that same folder. Okay, so we've got a clean slate. What is our goal for this lesson? Well, we want to create a server that listens for incoming requests so that we can visit that server in our web browser and have the server send back a response that says something simple like maybe hello world or welcome to our web page. So back in our text editor, the question is, how can we use code to create a server? The answer is that we need to use environmental jargon. So the first step is to realize that we are writing code for the Node environment, not the web browser environment. So back when we were writing code for the web browser environment, we could use the JavaScript language itself, right? The core of the language. We could say something like let favorite number equal 7, right? And that's valid JavaScript no matter which environment we are in. However, back in the web browser, if we wanted to do something web browser-ish, like respond to a click event or select an element, we needed to use special words, like remember the web browser has an object named document, and document is not part of the JavaScript language itself. It's just a word that the web browser brings to the table so that we as programmers can leverage the environment that we are in. Well, we need to do the same thing with Node. So we are in the Node environment and we want to do something Node-ish, like setting up a server. So we need to use Node's special words. So type this out with me, HTTP. And then we want to look inside that and call a method named create server, parentheses to call the method. And just a quick note, if you're using VS Code as your text editor, like I am, you might notice that when you type HTTP, it gives you all of these suggestions. And if you try to type a dot right after that, it's going to use one of the suggestions. So what you can do is type HTTP and then either hit the escape key on your keyboard to get rid of the suggestions, or just push the arrow keys on your keyboard to move around a little bit, and then you can include the dot and then create server parentheses. Now, HTTP is not part of the JavaScript language itself, but just like the web browser has the document object that we can leverage, the Node environment has this HTTP object that we're going to leverage. Now, we don't want the server that this method is going to create to just float around in outer space. So instead, let's store it in a variable. So at the beginning of this line, we can just say let, and then I'm going to say our app equals, but you could choose whatever variable name you want. You don't have to use our app. You could call it pizza or unicorn or anything. Okay, but the point is that we now have this variable that is a server, and we know that the job of a server is to listen for incoming requests. So let's tell the server to begin listening. So on a new line, I'm going to say our app dot listen. Right? So just like way back in one of our very first lessons, when we had a dog object and told it to jump, or we had a cat object and told it to meow, in this case we have a server object and we are telling it to begin listening. Next, what we need to do is tell the server what exactly it should do when it does receive a request, right? What should the server do in response to an incoming request? Well, that's exactly what these parentheses up on the first line of code are for. When we call the http.createServer method, we want to pass it a function as an argument. And then the server is going to run or execute or call that function every time it receives an incoming request. So you could make up a name for a function here, and then down here define a function with that matching name. However, since we don't really need to call this function anywhere else, why don't we just go ahead and create an anonymous function right within these parentheses. So I'm going to say function parentheses curly brackets, and feel free to drop down inside the curly brackets. And actually, before we start writing the body of our function here, let's first give our function 2 parameters. So right after the word function within these parentheses, let's say req, which is short for request, and then let's include a comma and include another parameter and name it res, which is short for response. Technically, you could make up any 2 names you want for the parameters, but these names make a whole lot of sense, request and response. Okay, and now within the body of our function, we can leverage the request and response objects that the server is going to pass into our function every time it calls the function. Now, we will learn more about the request object in a few minutes, but for now, all we really need is the response object. So remember our goal for this lesson. When someone sends a request to our server, we simply want to respond by saying, hello and welcome to our website. So within the body of our function, let's use the response object and call a method named end. Right? We want to end our response by sending a little bit of text that says, hello and welcome to our website. Okay, now before we save this file and tell Node to actually run it, there are 2 tiny details that we need to address. So first, in the Node environment, whenever we use a special Node word or ability, in this case HTTP, we need to explicitly tell Node to load or import or require in that functionality or that ability. So even though HTTP is part of Node, we still need to add a new line of code up at the very top of our file and say let HTTP equal, and then we tell Node to load or import or require in that ability. So we just say require parentheses, and in those parentheses we say quotes HTTP. Node will know what we mean with this chunk of code, and then we are storing that functionality in a variable named HTTP. So then in our code down here, Node will know what we mean when we say HTTP. Okay, there's only one more detail that we need to take care of before we save the file and take it for a test drive. Down on our very bottom line, within the parentheses for the listen method, we need to pass it a port number as an argument. Let's say 3000. Don't worry, I do not expect this number of 3000 to make sense right now, but it will come into focus very soon. Okay, now let's go ahead and save this file, and then let's use the command line to tell Node to run or execute our file. If you're using VS Code, you can open up your command line by pushing Control and the tilde key, or you can always click the View menu and then choose Terminal. Okay, in the command line, let's say node and then a space and then the name of our file. So my file is named test.js. Yours might be named something different, so keep that in mind. But after you type in node in the file name, push enter. And now at this point, our server is up and running. Right now, I want you to jump over to your web browser and let's try to send a request to the server. So up in the address bar, type this in with me. Clear out the address bar and let's say localhost. Localhost is the address for your own computer. And then we can say colon and then the port number that our server is running on. And remember, we chose a port number of 3000. So localhost colon 3000, push enter. Awesome. There we see the response from our server. Hello and welcome to our website. So at this point, we've accomplished the original goal of this lesson. We created a server that listens for incoming requests and it sends back a response. Well, that didn't take too long, so let's give ourselves another new goal for this lesson. So with a real-world website or web application, we know that you can visit different URLs to visit different pages. For example, a lot of websites have an About page or an About Us page. So if we came up into the address bar and after the 3000 added a /about and tried to visit that URL, we still see the exact same response. So let's give ourselves the goal of sending back different responses depending on the URL that the visitor is trying to visit. How about if someone visits the base URL, just localhost 3000, we send back text that says, hello and welcome to our home page. And if they visit maybe /about, we say, thank you for the interest in our company. So how can we accomplish that? Well, let's jump back into our text editor. And this is a great time to learn about the request object. Remember that every time the server receives an incoming request, it's going to run our function. Now, we've already leveraged the response object that gets passed into our function, right? We called response.end to send back this response. Well, now let's leverage the request object that gets passed into our function. The request object contains a bunch of information about the current incoming request. So if we want to be aware of which URL the user is trying to visit, all we need to do is dig into the request object. Let me show you what I mean. Within the body of our function here, maybe right before this response.end line, let's add a brand new line and say console.log. And what we want to log is req or request and then dot and look inside it for a property named URL. Okay, go ahead and save the file. And then we need to close or quit the current instance of Node that is running our old file or our outdated file. So down in the command line, push Control and C on your keyboard at the same time. Okay, that just told Node to stop running our previous version of our code because the listen method is open-ended or ongoing. It's just going to keep listening until we tell it to stop listening. So we stopped our server. And now that we've saved the changes to this file, we just want to start the server back up again. So just run the exact same command, node test, or whatever the name of your file is. Okay, now if we go back into the web browser, and if we try to visit localhost 3000 /about, and then jump back into the command line, you can see that that got logged out to the console, that /about. So now each time a request comes into the server, our function's going to run and we're going to see that value. So if you typed /pizza and tried to visit that URL, you better believe that you're going to see that in the Node console. And back in the web browser, if we just visited the base URL, localhost colon 3000, we just see a / with nothing after it. Now this might seem basic, but this really opens up the door to a lot of possibilities. Let me show you what I mean. So back up in our code, let's get rid of this console.log line. And then let's go ahead and cut this response.end line into our clipboard. So cut that. Okay, and now let's use an if statement to send back a different response depending on the URL the user is trying to visit. Let me show you what I mean. So let's say if parentheses, curly brackets, and for the condition in the if parentheses, we can just say if request.url equals quotes and then just a /, that would be the home page. So within the curly brackets for the if statement, you can paste in your clipboard and let's adjust it to say hello and welcome to our home page. Okay, and then right below this if statement, let's just set up another if statement. Say if parentheses, curly brackets. For this condition, let's say if request.url equals, and again, that's double > to check for equality instead of assigning a value. If it equals quotes slash about, well, then within the curly brackets for that if statement, paste in your clipboard, let's send back a response relevant to the about page. Say, thank you for the interest in our company. Okay, now let's go ahead and save the file and test it out. So down in the command line, let's quit this instance of Node. So Control-C. Be sure to click onto the command line area of your screen before trying to push Control-C. And we just want to fire the server up again using the newest version of our code in this file. So again, we just say node test. And over in the web browser, let's try it out. So if we visit just localhost 3000, hello and welcome to our home page. If we visit /about, thank you for the interest in our company. Awesome. Now, while we're at it, why don't we add a fallback so that if someone tries to visit a different URL, the world doesn't end and our server doesn't just sit there and hang or throw an error. Let me show you what I mean. Back in our text editor, if neither of these if statements is true, meaning if someone tries to visit a URL that is not the base URL, nor is it /about, well, we just want to handle that situation. So maybe right below this second if statement, let's just paste in our clipboard, or you could just manually type it out and say response res.end and say, we cannot find the page you are looking for. Okay, I'm going to save the file, come down to the command line, click anywhere in this command line area and push Control-C to stop the old server, and then fire up the latest version of our code, so node test. Come back to the web browser. So we see that our about page still works, the home page still works, but if I try to visit a bogus URL, we cannot find the page you are looking for. At this point, I want you to give yourself a pat on the back because you just created your first server. Now, I realize this super basic server might not seem very impressive, but it does open the door to all sorts of possibilities. So the question becomes, what's next? Where do we go from here? Well, so far our server or app can respond to the URL of the incoming request, but do you know what would make our server 1,000 times more interesting? If we could respond to the value that users type into form fields. And that's exactly what we're going to learn about in the next lesson. We will learn how to work with user-submitted data in our server. So perhaps we could include a question on our web page that reads, what color is the sky on a clear sunny day? And then we could have a text input field where the user can type, and then we could have a submit button that they can click, and then we can use our server to evaluate their answer and either send back a congratulations response that says, yep, that's the correct answer, or send back a sorry response that says, nope, try again, that's incorrect. This process of working with and evaluating user-submitted data is crucial to becoming a full-stack developer. However, before we jump into that next lesson, I do have an important quick note to share. When it comes to the server that we built in this lesson, I want you to know that you are the only person who can access or view your server. Remember, that's what the local host in our address stands for. It means your specific computer. In the real world, we would want other people to be able to access our server or application. So in the real world, we would send our code that creates the server, we would send that to a hosting company. That company would host our server for us and make it publicly available. And then instead of localhost 3000, the address for our server could be ourapp.com or superawesomeapp.com or whatever your domain is. Big picture, for right now, you can rest assured that later on in the course, we will indeed learn how to make a server publicly available. And when that time comes, you will be able to share the address to your server with your friends and family, and they will be able to access it and see what you built. Because let's be honest, sharing something that you created with the people in your life that you care about is the funnest aspect of learning anything new. and that includes programming. But for now, we are just getting started. We are just learning the basics, so it's okay that we are using localhost and that we are the only ones that can view the server. Okay, having said that, we are ready to move on to our next lesson and learn how to work with user-submitted data. Let's keep our momentum rolling, and I will see you in the next lesson. Hello everyone. In this lesson, we are going to learn how to receive form data from a visitor and work with that data in our server. Let me show you what I mean by giving you a sneak peek of the finished product of what we're going to build together in this lesson. So we see a bit of text. What color is the sky on a clear and sunny day? And then here is a text input field. Now if I type in an incorrect answer, so if I say orange and then click to submit, we see, sorry, that is incorrect. But if I click back to the home page and then type in blue and submit, we see, congrats, that is the correct answer. Now, this may not seem very impressive or exciting, but trust me, being able to respond to user input like this marks a huge milestone in your journey towards becoming a full stack developer, right? If you think about how you log into your bank's website or your email or any online account, you have to fill out a username field, and then you have to fill out a password field, and then you submit. And then the server decides if what you typed in is correct or not. So we're starting simple here and just checking to see if the user types in blue or not, but we need to learn how to walk before we can run. So how can we start building this together? Where do we begin? Well, in our previous lesson, we used the HTTP functionality of Node to set up a basic server. So as we've already seen, we can technically create a server this way, but the truth is that you can use Node to build just about anything, not just web servers. Now, this open-ended nature and flexibility of Node is great, but in the real world, we have a specific goal, right? We want to create a web server. So it makes more sense to use a solution that is less open-ended and instead is specifically designed for the purpose of creating web servers. And that's exactly where something named Express comes into play. So what in the world is Express? Well, let's start with their official description or slogan, and then I will explain it. So it says that Express is a fast, unopinionated, minimalist web framework for Node.js. But what does that mean in plain English? So I would say that Express is a bunch of pre-written JavaScript code for the Node environment that we can leverage. So Express takes care of 1,000 different details for us so that we can avoid reinventing the wheel and also so that we can keep our code more organized. Now personally, I'm not always a fan of leveraging pre-written JavaScript code like this. However, I am a huge fan of Express, largely because of these two words that I've highlighted here, because it is unopinionated and minimalist. Express doesn't automatically do a ton for us. It doesn't babysit us so much that it prevents us from learning, and it doesn't really force any rigid or dogmatic ideas on us. It simply provides functions or methods that are specifically designed for creating web servers. You can think of it like this. Node on its own without Express is like Legos. There's all kinds of different Lego block types, some that you'll want to use, a bunch that you will not need to use, and you can use these Lego blocks to build anything. On the other hand, if we use Express, we are still using Node, but Express gives us new Lego block types that were specifically designed to be used to build the one thing that we're trying to build, a web server. If that metaphor didn't make any sense, that's okay. Let's keep things moving. But before we move on, I do want to let you know that Express is not some small, seldomly used framework. So by us using Express, I'm not forcing some odd opinion on you. Express is absolutely the industry standard when it comes to creating web servers with Node. In the real world, you are going to run into Express all over the place. To give you a frame of reference, just in the last week alone, Express has been downloaded over 5 million times. So, at this point, the question becomes, how do we use or download Express? Well, we actually do not download anything from the Express website. Instead, let's jump back to our text editor, or more specifically, jump back to our command line. So I'm using VS Code, so I can just click View and then Terminal. And then in your command line, I want you to run the following command. npm, and then a space, and then install, and then a space, and then Express. Now before I push enter to actually run that command, I want to explain what's going on here. So first of all, what is npm? Well, when you installed Node on your computer, it automatically installed something else named npm. These letters stand for Node Package Manager. For now, we can think of npm as a giant grocery store of pre-written JavaScript goodies that we can leverage. Right? So for example, if you were baking a cake in real life, you probably are not creating your own flour from wheat. Instead, you're probably just going to the grocery store and picking up a bit of flour. So npm is this centralized place where we can grab all sorts of pre-written JavaScript goodies or packages, right? Node Package Manager. And then the second word here is install. We want to install something. What do we want to install? Express. That's the name of the package that we are interested in. So let's go ahead and push enter to run the command. Give it a few seconds, and now you'll notice that in the left-hand sidebar, npm automatically created a new folder for us named Node Modules. And if we look inside that folder, and if you look through this list, you'll see, aha, Express. If you're wondering why npm downloaded all of these other packages aside from Express, it's because Express depends on these other packages. To be honest, there's never really a need to actually open the Node Modules folder and look at all the different packages. I'm only doing that to show you that npm successfully downloaded the package for us. You'll also notice that npm created this new file named packagelock.json. For now, we do not need to worry about this file. Later on in the course, we will learn more about it. Before we move on, I do want to let you know that when you run an npm install command, npm is going to create these files and folders for you in whatever directory your command line is currently pointing towards. Remember, in my case, I created that folder on my desktop named First Node Experiment, and that's the directory that my VS Code command line is pointing towards. But if you're not using VS Code and you're using a standalone command line, that's just something I want you to be aware of. Okay, now moving on. We have successfully used npm to download or install Express. So now let's begin using Express in our code. So within my test.js file, the file that we've been writing all of our code in so far, I actually want you to select everything and delete it. We want a completely brand new clean slate in this file. This time around, we are going to create a server using Express. So things are going to be a little bit different. Now, just to jog your memory, remember that our goal is to create this application that receives the user input, and then we evaluate whether they typed blue or something else. Okay, so back in our text editor, our first step, if we want to leverage Express, is to import or include or require in Express. So type this out with me and then I will explain it. So say let Express equal require, and then parentheses, inside the parentheses, quotes, Express. Now this syntax is identical to when we said let HTTP equal require HTTP. The difference here is that Express is not a built-in part of Node. Meaning before we wrote this line of code, we needed to use npm to actually go out onto the internet and download Express for us. So when we say require in the Express package, Node will know to look inside a folder named Node Modules and it will know where to look. Okay, so this line of code gets Express ready. Now we can actually begin leveraging Express. And that's exactly what we're going to do in the next part of this lesson. So with this first part of the lesson coming to a close, you'll know that you're on track if you ran the npm install express command and it created a node modules folder in your project folder. As long as you've got that, you're good to go. You're right on track. So let's keep things rolling and begin writing code to actually use Express. And to get to that, I will see you in the next part of this lesson. Hello, everyone. Welcome to part 2 of this lesson. Let's pick up right where we left off. In the first part of this lesson, we used npm in the command line to download Express. And up in our file, we've written this line of code to get Express ready. Now we can actually begin to write code that uses Express to build a server. So let's create a new variable. So and then you can name it anything you want, but I'm going to name it our app. And let's set it to equal, and then just call Express. So this will create or return an Express application or server, right? That's leveraging that pre-written JavaScript code that we downloaded. And now we have a server that lives in this variable named our app. So now let's tell our server to begin listening for incoming requests. So on a new line, we can just say our app and then dot and call the listen method. And let's listen on port 3000. Okay, and then right above this listen line, let's add a new line to tell our server what it should do if someone sends a request to our home page. So let's use our app variable and then call a method, so dot, and the method is named get. I will explain what the word get means in this context a bit later on in the lesson, but for now, all we need to know is that we give it 2 arguments. So we could say a, b as placeholders. The first argument is the URL that you want to be on the lookout for. So let's just say quotes and then a /. This represents the home page or base URL. All right, and then the second argument is a function that Express is going to run anytime someone sends a request to this URL. So instead of this placeholder b, let's write an anonymous function. So function parentheses, curly brackets, and then drop down inside those curly brackets. When Express calls this function, it's going to pass it 2 arguments. So inside these parentheses, let's include 2 parameters, req, res. Okay, now within the body of our function here, what do we actually want to do? Well, when someone sends a request to the homepage URL, in response, we just want to send back a bit of HTML that would create this page with this text and form field. So back in our code, within the body of our function, we can use the response object from Express, and then look inside it with a dot, and then call an Express method named send. And what do we want to send? Well, instead of just simple quotes for a string of text, let's actually use backticks. Remember, this is the key to the left of your 1 key or right above your tab key. And in between the backticks, we are free to break down onto separate lines, like this. You don't have to do this. I'm doing this just to stay organized because I think HTML is easier to read for the human eye if it's on separate lines. So now we can just start writing HTML. Let's create a form element. So an opening form tag, closing form tag. Inside that form, why don't we create a paragraph? And inside the paragraph, we can say, what color is the sky on a clear and sunny day? Maybe right below that paragraph, let's create a form input field that the user can type into. So just create an input element. Input does not need a matching closing tag, but on the opening input tag, let's give it a name. So name equals and then quotes. And let's say sky color. I just made this name up of sky color. It doesn't matter. It could be unicorn or pizza or anything. Okay, let's also give this input an attribute named autocomplete and set that to off. You don't need to do this. I just don't like the annoying pop-up auto-suggestion feature in the browser. Okay, and then right below the input element, let's create a button so the user can click on it to submit the form. So opening button tag, closing button tag, and we can say submit answer. Okay, now before we save the file, let's address the opening form tag. Let's give it a couple of attributes. Let's say action, quotes, and let's say / answer. Okay, and then after those quotes, let's give it one more attribute named method and set that to equal quotes and say all capital post, P-O-S-T. Now I realize I did not explain what action equals / answer or what method equals post means. Don't worry, we will circle back to that in just about a minute from now. For the time being, let's go ahead and save this file and then come down into the command line and take it for a test drive. So let's run the command node test, or whatever your file is named, push enter, and then if you jump over to your web browser and visit localhost 3000, you might need to refresh the page, but you should see something that looks almost identical to this. Now here's where things get interesting. Let's try to fill out and submit the form field, right? So click into the field. Doesn't matter what you type, but just go ahead and submit the form. And we see some good news and some bad news. The good news is if you look up in the URL or address bar, our form redirected us to a /answer URL. That means that we typed out the HTML for that form correctly. And as you might have guessed, this is where the /answer comes into play. Whatever you set as the action for an HTML form, well, that's the URL that the browser is going to send the form results to. Now, I just randomly chose the word answer here, but there's nothing special about that. You could have set this to pizza or unicorn or anything. Okay, so that explains the action attribute, but what about the method attribute? What in the world does method equal post mean? Well, this controls the type of request that the browser is going to send to the server. In the land of the internet and HTTP requests, there are actually many different types of requests. But for now, in the context of this lesson, we really only need to be aware of two different types of requests: a GET request and a POST request. So in your web browser, when you visit a URL, so if I typed in google.com, my browser just sent a GET request to the Google servers. Or if I clicked on one of these navigation links at the top of Google, like if I clicked on their About link to go to the About page, my browser sent a GET request to that About URL. So when you're surfing the web, a GET request is sort of the standard type of request. If you manually type in a URL or if you click on a traditional navigation link, it's a GET request. You're saying to the server you want to get a bit of information. So if I go back to localhost 3000, my browser sends a GET request to the server. However, if I fill out this form and then try to submit it, my browser not only wants to get information about that new URL of /answer, but it also needs to send along its own data to that URL, right? It needs to send along whatever I typed into the form fields. So it needs to send that data, or in other words, it needs to post that data, hence the word post. So if I submit this form, we see cannot post to /answer. And that's because we never told our Express server what it should do in response to receiving a request to the /answer URL. Now, before we worry about actually evaluating the user's answer, let's first make sure that we actually understand the difference between a GET request and a POST request. Trust me, I've seen many different full stack development courses, and I feel like they always gloss over this difference, and it's usually confusing and a bit blurry. So let's run through a quick exercise to make that difference between GET and POST crystal clear. Back in our code, perhaps this method named GET right here is starting to make a bit more sense. We are telling our app what it should do if it receives a GET request to this URL. So let's do this. Let's scroll down to the bottom of this code and maybe right above this listen line, let's add a new line. and say our app, and then instead of .get, let's say .post. So we are going to tell our app what it should do if it receives a post request to the /answer URL. Okay, just like with the get method, we want to give the post method a second argument, so comma, and then we include a function that Express will run in response to this request occurring. So after this comma, include an anonymous function, so function parentheses curly brackets. Inside the parentheses for the function, include the parameters req and res. Inside the body of our function, let's just send back a bit of text that reads, "Thank you for submitting the form." So we can use the response object and call the send method a bit of text, "Thank you for submitting the form." Okay, now before we save this and test it out, I want to do something to make the difference between a GET request and a POST request crystal clear. What I want you to do is select these 3 new lines of code that we just wrote, copy them into your clipboard, and then right below this, but before the .listen line, just paste in your clipboard, so duplicate it. And on this new copy, I want you to change this word post to get. So on the second copy, it's our app.get. So if someone sends a post request to this /answer URL, this makes sense. But if someone sends a GET request to that same URL, let's do this instead. Let's just send back a bit of text that says, "Are you lost? There is nothing to see here." Okay, at this point, let's go ahead and save the file and then test it out in our browser. So let's come down into the command line and press Control-C to stop the old server. And then let's just run node test to fire up a new copy of the server with our latest code. All right, and then back in the browser, if I just go to localhost 3000 and fill out the form, submit, thank you for submitting the form. So this is in response to the post request to /answer. However, if I go back to the home page and then up in the URL address bar, if I manually type in /answer, that is a GET request. So that's why we see, "Are you lost? There is nothing to see here." So hopefully this illustrates the difference between a GET request and a POST request. A GET request happens when you type in a URL or you click on a traditional navigation link. A POST request typically happens when you submit a form, right? When the user wants to send or post a bit of data to the server. So even though in both cases the URL ends with /answer, our server is able to respond differently depending on whether it's a GET request or a POST request. All right, so now that we have at least a very general understanding of what a POST request is, let's get back to the actual task at hand. So when someone submits the form, we don't want to just say thank you for submitting. We want to actually evaluate their answer and tell them if it's correct or incorrect, right? And we are asking them what color is the sky on a clear and sunny day. So the question becomes, how can we access the data that the user submits from within our server? Well, the good news is that Express makes it very simple. So let's jump back into our code. And within the our app.post area, right, this is what's going to occur when someone submits the form. Let's actually get rid of this response.send line. So now we just have an empty body of the function, because before we send back a response, we need to decide if they typed in the correct answer or not. So we know that in JavaScript, we have a tool to do just that, and that is the if statement. So let's say if parentheses, curly brackets. Inside the curly brackets, let's drop down. Right after those curly brackets, we can say else, new set of curly brackets. Okay, and let's fill in the condition. So in the parentheses, right after the word if, let's say if x == blue. Now, I just typed in x as a temporary placeholder. So now the million-dollar question is, how do we actually access the user's typed in value here? Well, instead of the placeholder x, get rid of that, and let's say req for request, This is the request object that Express passes into our function, which contains all sorts of information about the incoming request. So within our if statement, we can say if req.body.skyColor equals blue. So the request object, and then body is the body of the post of what they're sending. It's the main meat and potatoes. And then we are looking inside that for the sky color property, because an HTML form could contain multiple fields. So we need to specify which specific field or value we are interested in. If you're wondering where this name sky color came from, remember that this will be exactly whatever you typed in for the input name when we were building the HTML for our form. Okay, so if this evaluates to true, then the user typed in the correct answer. So within our if statement curly brackets, let's just send back a congrats message. So response.send. I'm going to include backticks so I can drop down onto multiple lines. And in between the backticks, let's just send an HTML paragraph that says congrats. That is the correct answer. And then maybe right below the paragraph, let's include an HTML link that they can click on to go back to the home page. So A for anchor. In the middle, let's say back to home page. And on the opening A tag, let's give it an href. And then let's just say / to represent the home page. Okay, but if the user types in something other than blue, that's incorrect. So we need to fill in this else part of our code. So to save a bit of typing, let's just copy and paste these lines right here from the start of res to the end of the closing parentheses for the send. So I'm just going to select that and then copy it, and then in the else brackets, I'm going to paste in my clipboard. This time around, we just want to change the message that's in the paragraph. So this time we'll just say, sorry, that is incorrect. All right, now before we save our file and test it out, we need to do one more thing. By default, out of the box, Express actually will not add the user's inputs to the body object that belongs to the request object. So in order for this code that I'm selecting right now, in order for this to work, we need to tell Express to enable that feature. So do this with me. Scroll up to the very top of our file, and right below this line where we say let our app equal and then we call Express, right below that, let's add a new line, and let's just say our app.use. And now the rest of this line of code is not going to be educational in the slightest. This is more of boilerplate code that you would find on the Express documentation website, and then you would just copy and paste it and include it in each of your new Express projects. So this is not something that you need to memorize. But let's say express.url encoded, parentheses to call that method. Then we give it an object, so curly brackets. Inside those brackets, we include a property named extended, and then colon, and set it to false. You might need to pause the video lesson for a minute to type this in with me. But again, I'm not going to explain it because this is just boilerplate code and it's not educational. All it's doing is enabling that feature in Express so that the user's input is easily accessible from the request.body object. Okay, at this point, let's go ahead and save our file, come down to the command line, stop the old server, fire up the new server. Let's go back to the browser. If I refresh the home page and type in something other than blue, submit, sorry, that is incorrect. But if I go back to the home page and type in blue, congrats, that is the correct answer. Now you might be thinking to yourself, what if someone types in all capitals blue or just the first letter capitalized? We see sorry, that is incorrect, even though that is the correct answer. So really quick, to make our code case insensitive instead of case sensitive, all we need to do is come into our if statement, and right after the request.body.skyColor, just say .to uppercase, parentheses to call that method. So whatever the user typed in will be converted to all capitals, and then we can just check to see if that equals, and then for here we can just say all uppercase blue. So let me save that and then restart the server. Jump back into the browser. If I type blue, or maybe leave the E lowercase just to really prove a point and submit, congrats, that is the correct answer. And that's actually going to bring this lesson to a close. In our next lesson, we are going to do two things. Number one, we will review why this example app was so important. And number two, we will identify the missing ingredient that is going to let us create more advanced applications. Let's keep our momentum rolling, and I will see you in the next lesson. Hello, everyone. This is sort of a bigger picture video. We are not going to be writing any code. Instead, in this video, we are going to answer 3 questions. So number one, why was the app that we built in our previous lesson so important? Number two, what is the missing ingredient that will let us build more advanced apps? And finally, number 3, what are we going to be doing for the remainder of this course? Let's start up at the top with number 1 and ask ourselves, why was this application that we just built so important? Well, it's because we are now at least a little bit familiar with the process of receiving an incoming request, making a decision based on the user's input, and then sending back a response. Now, understanding this basic cycle of request and response is insanely powerful because that's really all any application does. The real question becomes, what do we do in between the request and response? So I want you to think of a sandwich. Typically, the most interesting part of a sandwich is whatever is in between the bread. So if we think of the incoming request as one piece of bread and the response that our server sends back as the other piece of bread, that would mean that the peanut butter and jelly or the meat of our sandwich is our if statement that checks the user's sky color value. Now, granted, that's a pretty boring and simple sandwich that we made. But that's not the point. The point is that we now know how to make a sandwich at all. That's huge. Now we just need to learn how to put more interesting ingredients into our sandwich. Which brings us to the second question of this video. What is the missing ingredient that will let us build more interesting or advanced applications? Well, if we look at our course overview, we are now at least a little bit familiar with the first 3 items. So as you can probably guess, the missing ingredient is MongoDB. Technically, the missing ingredient is any database system, but in this course, we are going to be using MongoDB in particular. Now, before we worry about what a database is, let's first look at the big picture. So the app or server that we built in our previous lesson can read the user's input, right? We were able to determine if they typed in blue or not. But as soon as the server sends back its response, that data that the user typed in and submitted is gone. Our server does not remember it. Now, for certain simple applications, that's okay. But for most complex applications, we need to have some sort of permanency, right? Eventually, we are going to want to remember or store the user's data. And this is where databases come into play. So for example, what if instead of asking the user what color is the sky, what if instead we were asking them to register for a new account? So they would need to enter a username and a password. Well, we would want to permanently remember those values that they choose so that we can reference them the next time they try to log in. That's just one example. There are millions of examples. Databases are everywhere. Anytime you post a comment on Instagram, it's getting saved into a database. Or anytime on Twitter you send out a new tweet, that's being saved into a database. Really, anything you do on the internet that is permanent likely involves a database. Now, instead of us learning about databases in a cold, soulless, academic, isolated vacuum, we are going to learn about them within the holistic context of creating applications. To be more specific, full stack JavaScript applications, which segues nicely into the third and final question of this video. What are we going to do for the remainder of this course? Well, aside from a few bonus or extra credit topics at the very end of the course, we are going to spend the rest of our time together building two applications. Let's call them app number 1 and app number 2. App number 1 is small, unorganized and messy, and oversimplified. On the other hand, app number 2 is big, organized, and very real world. Now, you might be wondering why we're going to build two apps instead of just one, right? You might think, why not just skip the small, unorganized project and just focus all of our effort on the big, organized project right away? Well, trust me, there is a method to my madness. So right now, our focus is on learning the very basics of a database. However, if we jumped straight into app number 2, we would need to worry about things like templating engines, user registration, user authentication, security, error handling, how to keep our code and files organized, and much, much more. Trust me, we don't want to deal with all of that in this moment. So for the time being, we need a project that is complex enough to need permanency in a database, but simple enough that we don't overwhelm ourselves with all of these topics on the screen right now. That's actually my biggest pet peeve with other courses and instructors. They structure their example projects in a way to where you're being introduced to 10 new topics at once, and you just drown in a sea of new topics all fighting for your brain's horsepower at the same time. So the idea in this course is that app number 1 will get us comfortable with the big picture, the basic mechanics of building a full stack app, and then once we've absorbed some of that and some of it becomes second nature, we can move on to app number 2, where we do worry about real world complications and best practices, so on and so forth. Now really quick, right now, I want to show you a sneak peek of both app number 1 and app number 2, just so you know what to expect. So here is app number 1, and this is the finished final product that we are going to be building together. It's a very simple to-do app, and you can see there's a text field here, and if I type in feed the dog and then either push enter or click the blue submit button, it adds it down here. And let me add a few more items. Maybe pay attention to the cat, and maybe buy fruits and vegetables. Okay, so now I've got this list of items, and each item has two different actions. You can edit it or delete it. So if I click edit on feed the dog, this little pop-up appears, and I can type something new in. I can say feed the dog, maybe add the word today at the end of it, push OK. You can see it gets updated. And then obviously I'm free to delete any of the items I want. So if I want to delete buy fruits and vegetables, just click delete. We see this little pop-up. Do you really want to delete buy fruits and vegetables permanently? Yes, I do, so click OK, and it's gone. Now, the whole point of this application is that our list of items is being permanently stored in a database. So even if I closed my web browser and then came back and revisited this app maybe a year or two from now, this data, these items, would still be here waiting for me. Or better yet, I could step away from my computer and maybe use my phone or a tablet, and my data would still be available to me. Because instead of just localhost, we are also going to learn how to push this app up onto the internet so you can share it with your friends and family. So in the address bar, if I instead visit this URL, because our data and database lives in the cloud, you can access it from any device. So this is pretty fun. You will get a URL that you can share with your friends and family. This is just my example temporary URL. You will receive a new unique URL for yourself, and then you can see them add new items to the list. Big picture, there's not a whole lot going on with this app, but it is great practice of learning how to stitch together our three environments: the web browser, Node.js for the server, and MongoDB for the permanency or database layer. Okay, so that's a review of app number 1 that we are going to build together. Now let's take a look at the more complex app number 2. So this is what the home page looks like if you are not logged in. It shows you a registration form to sign up for a new account. If you try to sign up for a username that already exists, that someone has already used, you get a real-time feedback message. That username is already taken. So if I add unique at the end of it, good to go. If you add something that is not a valid email address, you get a warning in real time. You get the idea. Now, instead of creating an account in this moment, let's just log in to an existing account to show you around. So up in the header, you can log in. As soon as I sign in, you can see the home page looks very different. By the way, this is a journal or diary type of application. So you can see the home page, now that I'm logged in, reads the latest from those you follow. This is essentially a very basic social network type of application. These are articles or journal entries written by the people that I follow. So I can see this one's titled Destroying Furniture is Fun, written by Kitty Doe. So if I click on that, here is their article. And I can even click on their name to go to their profile. Up in the top right menu bar, I can click on my own circle to go to my own profile. So I have 3 posts, I have 1 follower, I'm following 2 accounts. We can click on that. You can see I'm following Barks a Lot and Kitty Doe. Also back up in the header, I can click on this icon to search for the content that I'm interested in. So if I search for the word furniture, in real time we get search results. So we see Destroying Furniture is Fun, that existing article by Kitty Doe. If I search for something that's going to return multiple results, like the word post, there we go, because I used that word in my title. You get the idea. Let's close this live search results feature. I can click on this green Create Post button to obviously create a new post or article. Obviously, a user is able to edit or delete their own existing articles. Okay, changing gears. If we look up in the header, we can see a chat or conversation looking icon. If you click that, it opens a chat box, connects you to the chat room, and this is not a one-on-one direct messaging inbox system. This is more of an old school traditional public chat room. So I can type in a message and say, hello. And any and all users that are logged in will be placed into this same chat room with me. In the real world, a public chat room like this would probably just be taken advantage of by weirdos and creeps and malicious users, but in the context of this course, I think it's a fun programming exercise. So I'm logged in as the Brad user in this browser, but I actually have a secondary browser. In this window, I'm logged in as the Kitty Doe account. So if I connect to the chat room here, I can say, meow. And back in this window, you can see that that message appears. Again, this is just a fun programming exercise to see what a server can really do. Being able to have real-time, 2-direction communication of data like this is a lot of fun to set up. Okay, and then finally, if I jump back to the home page of the application, remember this is my personalized feed because I'm logged in. However, if I use this button in the top right to sign out, you can see the home page now correctly treats me as if I'm a guest. All right, and that concludes the sneak preview of the finished product of app number 2 that we are going to build together in this course. Now, to bring this full circle, what do app number 2 and app number 1 have in common? Well, they both use a database to store data permanently. In the case of this simple app number 1, that's just the to-do list items. In the case of the more complex app number 2, the database is storing the usernames, the passwords, the article posts, the relationships of which users are following which other users, so on and so forth. So, where do we go from here? Well, in our very next lesson, we are going to begin learning about databases, in particular a system named MongoDB, and as soon as we learn even just a little tiny bit about MongoDB, we can begin to create this to-do list app together. I'm super excited because this marks the point in the course where we can finally begin to build real, meaningful, fun applications. We've eaten enough of our metaphorical broccoli. We worked through the 10 days of JavaScript to understand the programming language itself. We learned a bit about the web browser as a JavaScript environment. We just learned a little bit about Node.js and how it can be used to create a server and what the whole point of a server even is. And now finally, we just need to fold in a little bit of understanding of what a database is, and we will be off to the races. So let's keep our momentum rolling, let's get excited for databases, and I will see you in the next lesson. To get immediate and lifetime access to the full 27-hour video course, you can find a coupon link in the description for this video. Thank you so much for watching, and take care.